Hello and welcome to the Atlas Corps of Engineers PCS 7 Toolbelt series, where we will be going over some of the tools that we have developed to make PCS 7 project programming simpler and more efficient. In today's video, we'll be going over our Interlock Import Tool, which we use to program our interlock cause and effect as well as safety matrices cause and effects that we have within our PCS 7 projects. In order to properly demonstrate our Interlock Import Tool, we've gone ahead and created a list of tags and theoretical interlocks. And now if there's any systems or process engineers watching this video, please don't roast me. This is just something we made to demonstrate the tool, not really demonstrating, what actual interlocks would be. Let's start taking a look at our interlock importing tool. And the best way to start is by actually looking at our interlock template. This is the template that we use for all projects for just interlock cause and effects as well as safety matrix cause and effect tables. First, let's take a look at the cause side of the cause and effect matrix that we've built. We have our causes formatted for PCS 7 specifically. And if you are somewhat familiar with PCS 7, you might recognize that the total connection column here on this cause side of the table represents the interconnection that would be inserted on a given interlock block. Another thing that's worth pointing out about our interlock template is that it goes beyond formatting the interlock connection for PCS7, but it also formats the texts that would be inserted in an interlock block that are what is seen by operators on their HMI. And because our interlock template was built with PCS7 in mind, it also works with any of the interlock blocks that have voting logic. And as long as the voting logic is correctly defined within our interlock template, it can successfully be imported from this Excel sheet directly into PCS7. One last thing to touch on about how our causes are formatted for PCS7 is the inversions of the inputs. If you have had some experience with PCS7, you might have run across during testing where a bulk of the issues you find out is that some inputs are inverted when they're not supposed to be, and some aren't that need to be. Thankfully, our Excel format allows us to define directly whether or not an input is an energized to trip or de-energized to trip, aka whether or not it needs to be inverted or not on the interlock input. This allows us to avoid these types of common issues and focus our efforts in order to make the project development more streamlined and efficient for everybody involved. One last thing I want to touch on before actually demonstrating our Interlock Import Tool is how our effects are formatted. And it's very similar to our causes in that our effects are formatted in a way to directly correlate to a block within PCS7, in this case, the actual interlock block itself on the effect chart. And this is just another advantage of the fact that our sheet is designed specifically for PCS7. So if we look at our interlock cause and effect sheet, we can tell what block will be on what chart and what number it will be because of the way we list out our causes in the Excel rows you can see. For example, if I wanted to know what the first input on the FIC 1005 interlock should be, I can reference this interlock cause and effect list and say that the first input on FIC 1005 should be the IO fault for FIC 1005. Okay, now that I've gone over our interlock matrix formatting, let's actually see why we have it that way. And let's import some interlocks that I've just shown you into our project. The first step of the importing process is actually an export. We go into Process Object View, filter our parameters based on the relevant items that we need, and export that view to a CSV file. Once this project object view export file has been created, we then move it to the same location where the interlock matrix is stored, and then we can use the tools built into the interlock matrix to actually move the interlocks directly onto that same export file, which then can be re-imported to this project directly. Now, we would show you how our interlock matrix Excel sheet actually functions and correctly populates the interconnections for these interlocks in this process object view export. But magicians need to keep their secrets. And so in order to show how much time this takes, I have kept the static image here for the same amount of time that it took me to take this export view, import the interlocks from the Excel matrix, and then have it ready to re-import. Now that our Interlock Import Tool has taken the interlocks on the matrix and inserted them on that process object view export, the next step is to re-import that same process object view back into the project. Now that we have successfully imported the process object view, we can now see that the interlocks and their interconnections have been successfully imported, and we can even go and open up charts and see what those look like. So, as we look through our charts, we can see that our interlocks were successfully imported. And if we were to compare these with the interlock matrix, we would see that they match exactly as they should. Now, as this was a real project, as you can see, there's missing inputs, I/O, things that obviously this would need to be done before we can move forward on testing. But because of the time saved with our Interlock Import Tool, we could focus on those things next. And if you stick around and watch the rest of our videos in this series, you might find that we have some tools that save time there as well. So, all of us at Atlas Corps of Engineer hope our video about our Interlock Import Tool has been helpful and educational. And we ask that any questions or comments you have about this tool, you just leave below in the comments.